You need to start building with MCP servers right now. What used to take development teams months and cost $5,000 to $50,000, you can now build by yourself in a day. And I'm not talking about some watered down version, I mean actual tools that solve your specific problems. These little automation tools can handle just about any repetitive task you want to hand off: sales prospecting, personal finance tracking, investment research, nutrition logging, market research, content research, travel planning. You're not limited by coding skills anymore. You're only limited by your imagination. Here's what I mean. Instead of spending 30 minutes every day manually looking up and logging your nutrition data, you just type, "I had a sweet potato and chicken breast," into your computer, and it automatically logs all 20 micronutrients for you. You get the health benefits of comprehensive tracking without the soul crushing daily grind. Or imagine this: that sales research you spend 10 hours on every week, build a custom research tool this weekend. Type, "Find me 10 SaaS companies that raised Series A in the last month," and get everything in 2 minutes. And the best part? These little automation tools are virtually free to build. To make this work, you need to understand three unlocks. I call them the connection, the configuration, and the description. These three things are what separate people who try this and give up out of frustration from people who actually build tools that free them up to spend more time with family, to enjoy hobbies, to travel, to build a side hustle, and anything else you'd rather do than monotonous work. Once you understand these three unlocks, you'll be able to build whatever you need. And I'm going to show you exactly how to master each one. Let's go. Now, before we get to the three unlocks, I want to show you the end result of the project that we're going to do today. And I don't want you to focus on the end result of the project necessarily. What I want you to be able to do today is to brainstorm ideas in your own life of ways that you could use these principles, not necessarily this exact use case, but these principles to build these MCP server automations for yourself in your own life that are customized to the ways that you could use it in your life. We're going to just go up here to Claude Desktop, and we're going to say, "I ate a sweet potato and a chicken breast for lunch today." And now it's going to start thinking about what it needs to do. So yeah, then it's going to say, "I'll help you log that in your nutrition track." And then it's going to go back and it's going to get the nutrition information for chicken breast. Now it's going to ask us to describe how much we had of each. Now it's going to go and it's going to get the nutrition information for both of the items. Okay, and look at this. We're going to go over to our Google Sheet and we're going to see that this isn't logged yet, but it will be as soon as we get done having this conversation. So we tell it what time we ate it, then it shows us what it's going to log. We'll allow it. It's going to log that meal. Now let's go, and we can see that the sweet potato was logged, and so was the chicken breast. It had the date and the time. Now we have access to all the micronutrients that we've taken in the day, and then we can ask Claude to give us recipes that will help us fill the nutrient gaps that we have. So let's do that. So we ask it to give us recipes. So now it's going to go and it's going to check what we've eaten today. So now it's calculating our nutrient gaps and then giving us some recipe suggestions that will help us fill those gaps. So with that being said, let's go on to the first unlock, which is the connection. How we get our MCP server to connect to Claude Desktop. We need a way for Claude to be able to connect to these tools so that it can use it. And each MCP server has a production URL or a test URL. Basically, this is just an address on the internet that tells Claude where to go to connect to these tools that we have connected here to this MCP server. So in order to do that, we're going to double click on this MCP server, and then in every node in NAN, there is a little link right here. We'll click on the docs for the MCP server. We're going to scroll down until we see a little chunk of JSON that looks like this, and then we're just going to copy this, and we're going to go over to Claude Desktop. Once we're here, we're going to go Claude, and we're going to go Settings. And the good news is that this works for the free version. So you can download Claude Desktop right now. You don't need to pay anything. And this will be you'll be able to do this in the free version of Claude Desktop. So then we go to Developer, and then we're going to go to Edit Config. And it's going to open this up in our Finder. We're going to double click on Claude Desktop Config. And that's going to open up a file that looks like this. It might look slightly different on your computer, but this is what it's going to look like. So we're just going to we're going to select that all, and then we're going to paste the JSON that we got from this little chunk of code right here into our Claude Desktop config. And you're going to see that there are a couple placeholders. The one that we're concerned with right now is this MCP URL. So we're going to go back to our N8N instance. We're going to go to the production URL, and we're going to click this, make sure the MCP URL is copied to our clipboard, and then we're going to come back to this config file and we're going to replace this placeholder with our actual address or URL to our MCP server. And then we're going to save this file. One other thing that I want to mention is that it's important to have authentication, and bearer auth is the best one. So we're going to create a bearer token right here. We're going to select this. We're going to double click here. We're going to go to authentication, bearer auth. I'm going to go new, and we're just going to paste that in here. We're going to hit save, and then we're going to come back here and we're going to paste that into our auth token variable right here. We'll hit save. We quit Claude Desktop, reopen it. So that's how you connect your MCP server to your Claude Desktop, and this would work the same way for every single MCP server that you create here in NAN. Okay, unlock number 2 is configuration or tool configuration. So in this case, this MCP server trigger has access to 4 different tools. And essentially what this allows is it allows Claude to connect to these tools so that it can control those tools. Now, Claude by itself doesn't have access to tools. Basically, it's just a large language model. You can ask it questions and it can respond. But now that we're setting up this MCP server, it can actually go out to third parties, to databases, get information, bring it back, and do something with it instead of just being stuck kind of in its own brain. So this really has unlimited possibilities. When you connect tools to Claude, you can do just about anything that you want. Now, it's important that these tools are set up correctly, because if they're not, it won't matter at all. If there is one thing out of place for these tools, then Claude won't be able to use it. So let's look at this as an example. We have a bunch of different settings that we need to make sure are correct inside of this tool, and that is the configuration that we're talking about. It has to be done correctly. Now, this is an HTTP request tool, which gives us almost unlimited flexibility where we can access just about any API. So in this case, we are accessing a database programmatically. We're telling Claude about a database that exists somewhere out there in the world that holds information, nutrition information, about the foods that we put into Claude, or the foods that we tell Claude that we ate. And this particular database is managed by the USDA. So it has mountains and mountains of data on foods and the nutrition that is tied to those foods. So essentially what we're doing here is we are going out to that USDA API or that database, and we are telling it we want the data that you have or the nutrition facts that you have recorded about these particular foods. And then the USDA API will say, okay, it looks like you're talking about these foods, and it sends them back to our MCP server and gives them to Claude to do something with them. We say, hey, USDA, we're interested in finding the nutrition information about sweet potatoes. Can you send us back all the different foods that you have that are related to sweet potatoes? It sends them back. Claude looks at them and decides on which of those foods matches the food that we mentioned in our text or in our prompt to Claude. Some of these other settings are page size, so we give it a value of 10. So we say we only want 10 results per page. The data type, this one is just kind of unique to USDA. We won't go into too much detail here. And then this one is page number, where we say we only want to get one page back, and then we want to sort by data type keyword in alphabetical order. And then down here is a very, very important setting, which is optimized response. And we'll say field containing data foods, include fields selected, and then we specify we only want the FDC ID and the description. Now, the reason that we put FDC ID in description as the foods that we want is because this is a search tool. We're going to the USDA database and we're saying, find all of the foods that are related to chicken breast, or find all the foods that are related to sweet potato. And it sends back a list of 10. And the reason why we don't want the nutrition data yet is because we want to make sure that the food that we are going to record is actually the right food. So say we say sweet potato and it comes back with sweet potato chips. Well, we didn't eat sweet potato chips. We ate a sweet potato. And this particular tool search might send back sweet potato chips, and we don't want to log that. And so we give the whole list of all of the items that come back from the USDA API that have sweet potato in it, and we say, and Claude will determine, okay, this is the one that we actually want. They didn't say sweet potato chips, they said sweet potato. So then Claude stores the FDC ID and the description in its memory so that we can use that information to call a tool in the future. And the reason why we do this is because if we don't specify the fields that we want, if really we're only interested in these two fields, and we don't care about all the information that comes, all the other information that comes back from the USDA, and in fact, it might ruin our MCP server altogether. If too much information comes back, then Claude will get overloaded and it won't be able to work. So we really want this response to be very, very particular. We want to get very, very specific about the information that we want back so that we keep the memory as tight as possible and we don't overload Claude with so much information. So once we do this search and Claude determines which food we're interested in, it will again store the FDC ID and the description and in its memory, and then it's going to come back and it's going to call this tool, which is get food nutrition. And we need to make sure that this is set up correctly because um, take for example right here, let's say that Claude didn't store the FDC ID. Well, if it didn't store the FDC ID, this tool would not work because we need to go to we need to go back to the USDA database and we need to give the USDA database an FDC ID so that the database can go and search for that food in its database and then return it. If we don't give the USDA API an FDC ID, then it will tell us, I don't know which food you're looking for, I can't help you, and it will come back with an error. And so it's very important that we set up this tool such that when it goes back to the USDA API, that it can give the database the exact FTC ID that we found from this search function right here, or else we will get an error. So this is all part of configuration. These are the things that have to be right, and they're either right or they're wrong. If anything in here is wrong, this will very likely break. So configuration is crucial. And so that's just one simple example of URL, but then we have the credentials. So we have to basically give the USDA a password that says that we're authorized to access the USDA API, and we get that through the USDA website, which we don't need to go through now. In this case, now we want to send query parameters, and we're only interested in a certain set of nutrients. So the nutrients that come back with the food are going to have an ID as well. So we just say, only send us back, for example, vitamin A or D, B, C, and iron. Those are the only ones that we want. Don't send everything else back because it's going to overwhelm our system. So this is all a crucial part of making sure that this MCP server works, is that these tools are configured correctly and that all of the settings are right so that it both works for Claude, it doesn't get overwhelmed with too much data, and that we can give the API the information that it needs to actually perform the search. And if any of these break down, then it's very likely that the tool will break and the MCP server breaks. So tool configuration is extremely important. When we come over here to log meal to sheets, here's another example. This one is not an HTTP request, but is a Google Sheets tool. And it has a bunch of fields that we can fill out that are kind of made out of the box. So for example, we make sure that we're connected to the right account. We're going to set our tool description manually, and then we're going to do a sheet within a document. And we want to make sure that we append a row. We don't want to clear a row. We don't want to create a new sheet. We don't want to delete a sheet. We just want to append a new row to the existing sheet. And if this setting is off, our MCP server won't work how we want it to. So we got to make sure that that setting is correct. We got to specify the document that we're interested in, which is this one. And we got to say from the list, daily meals, we got to say that this is the actual sheet that we want to append a row to. So there are a lot of settings that we have to make sure are input correctly. We're going to map the columns automatically because we're setting this up very carefully. Claude is going to know which columns this sheet has. And again, these tools are pretty much binary. They either work or they don't. They're pretty finicky, but the good news is once you get these set up correctly, they will run and they will be very, very reliable. So now we're going to move on to the third part, which is description. Okay, description is the third unlock, and this is talking about tool descriptions. And these are absolutely crucial to the functionality of your MCP servers, and it's vital that you get these right. Now, like we've talked about, you have to connect it to Claude, which is very important. It either works or it doesn't work. And then you have your tool configuration, which either works or it doesn't work. And then your tool descriptions are not so black and white. You have to work to make sure that these are functioning the way that you want them to function. And here's the reason why. Claude is now connected to this MCP server, but it cannot see what these tools do. It sees that it has access to the tools, but it doesn't know what the tools do. And that is why descriptions are incredibly important. So we're going to look at this one here, and you're just going to see how detailed this is. So it tells it when to use it, because you think about it. If we want to go and we want to log foods that we ate, say just like we did in the opening example, that we tell it that we ate a sweet potato. Well, if it comes here and it tries to just start logging the meals, it's not going to work because it doesn't have any information to send to Google Sheets. And so nothing will happen. It just won't work. It can't come here. This is get daily meals. So this will try to get all the meals that you've eaten for the day, but that's not the goal if you're telling it that you ate sweet potato. You don't want it to go get the meals. You want it to log a new meal. And here, get food nutrition, you can't use this tool unless, like we mentioned, unless you have an FDC ID. And the only way you get an FDC ID is if you come here to search foods. So we need to tell Claude what order these tools are to be worked in. And even beyond that, not just the order, but what the tools need to succeed, and then what Claude should expect to be returned from those tools. So for example, with search foods, what does it mean it need? Well, we have all of these settings set already, but you'll notice here that there is from AI right here in this value. And that is because the way that this search tool works is that it uses a keyword to go to the USDA API in order to get results back. If it doesn't have a keyword, imagine if you said sweet potato and then it just sent something blank to the USDA API. The USDA API is going to have no idea what food you're looking for. So this tool will not work unless if it has a keyword or a food name to be sent along in the API request to the USDA API. So what do we do here that helps Claude know that to send that keyword? So we say when to use. User says I ate food. User mentions any food item. You need to identify a specific food to get nutrition data. So this is kind of just giving it a general idea of when this tool is to be used. So we said at the beginning, I ate a sweet potato I ate chicken breast. So it knows, oh, this is probably a scenario where I'm going to call the search foods and I'm going to go try and figure out what the FDC ID is of those foods. So then we say here, input. Our input is a query. We say, for example, apple. But now, since we did sweet potato, it changed the query to sweet potato. And when we did chicken breast, it changed it to chicken breast. But this is just giving it an example input so that it knows what it needs to send down to this tool in order for this tool to work. And then right here, it specifies the output, array of matching foods with FDC ID and description. So we tell it, we've said that we want to get the FDC ID and the description out of this tool, and then we're going to send that back to you, Claude. So this is kind of like Claude and the tool having a conversation. The tool just saying, here's what I do, here's what I need, and here's what I'm going to give you back. And here are the times when you should use me. Claude can know what to expect after this is done running. And then we just give it an example usage. So we walk it through every single step of the process so that it understands what to look for and how to run this tool and when to run this tool, and just gives it a basic overall idea of what this tool is all about. And then it says here, next step, after user provides portion, use the first results FDC ID with get food nutrition tool. So it's saying once you get the correct food here, then you need to pass it on to the get food nutrition tool. And then it gives it tips. If no results, try a simpler search term. So basically, we're just telling Claude everything that it needs to know to interact with this tool in a way that will increase the likelihood of success. A really bad tool description would be use search for foods in the USDA food data central database, and then end it. Because Claude needs more context. It needs to understand what is at stake here. It needs to understand what to give it, and it needs to understand what is going to come back in order for this whole process to function correctly. Because again, if we go in order, we need to search foods first. So we tell Claude that that's the case. Then we need to get the food nutrition. So if we open this one, and we look at our description, we say get detailed nutritional information for a specific food after the user has selected it from the search results. So it's saying don't use this tool until we have search results from the search foods tool. And then it says when to use only after using search foods and user selected a food. So it knows not to call this if we haven't called the search foods and we haven't selected the food. And then it says when to use it. You have an FDC ID from search results. So basically it's telling Claude, do not call this tool until you got an FDC ID back from the search tool and you have it logged in your memory. And then it also puts in a caveat that the user must specify how much they ate, which you'll notice at the beginning, it did ask. It made us tell it if it was a big sweet potato or how many ounces or grams of chicken breast we ate, because it needs that information in order for this tool to be used correctly. And we tell Claude that in this tool description. Then we give it an example input, which includes an FDC ID and our portion in grams so that it can convert it and actually track it accurately based on the amount of food that we ate. And then we're going to give it kind of an idea, common portion conversions. So 1 cup of spinach, 30 grams, cup of pasta, 150 to 200 grams. It gives it some conversion metrics that will help it to perform this action more successfully. And then we give it an output to expect. So we basically say, hey, Claude, we know you can't see the tool, but we can, and this is how we set it up. We're going to only return these nutrients to you, so you can expect to get these back. And if you don't get these back, there's a problem, and we need to work through that problem with the user. But most of the time, this will work correctly. But we're giving Claude an idea of what's going to come back from this tool so that it knows what success looks like. And then again, we give it an example usage, and then we give it next steps. Immediately use log meal to sheets. So we give it the next step in the process so that it knows where to go next. And then we give it just some important criteria here that will help, again, give it kind of more context on how to use this tool. So these descriptions are very important. If we would just say get detailed nutritional information, period, this tool will have very low likelihood of succeeding. So this is very, very important that we make this description correct and accurate. So then we come here to log meal to sheets. Let's look at our description here. So we say save meal to the user Google Sheets, and we say the AI must populate every field below for every tool call. No field is optional. No field may be left blank. No field may be omitted. And then we go on and we give it all the things that need to be true and in terms of the field definition. So you'll notice that these nutrients are the same ones that we got from the Get Food Nutrition tool that we just previously came from. So it knows to expect these, and it's going to log those up into the Google Sheets. And then we say an input template, this is what it might look like. A plain example, we just take unsweetened almond milk and we say this is what it would look like if it was unsweetened almond milk. Again, just giving it more context as to what we're looking for and what the tool needs in order to execute effectively, accurately, and consistently. And then how to populate, we give it more instructions. Always include date and time. And so this is kind of what you should be looking for when you're building your tool descriptions, to make sure that that Claude Desktop knows in which order it should call these tools, and then B, what those tools are going to expect in order to work correctly, the information that Claude needs to give the tools to work correctly, and then also what Claude should expect back from those tools so that it can complete the process and do it in an orderly manner that makes it so that each step in the process has all of its needs, all of the requirements checked so that the process works. And then if we look at this last one, this tool description, it says, retrieve all meals the user has logged for a specific date to calculate their total nutrition intake and compare against RDA. So when to use. User asks, what have I eaten? Or show me my summary. Or, before generating a recipe recommendation to know what's missing. So if I ask for a recipe, it's going to know, oh, this is a tool that I should call before generating a recipe recommendation, so I make sure that my recommendation is based on the nutrient deficiencies that the user has during that day. And so another one could be when the user asks about the progress. It just gives a couple scenarios when to call this tool, and then the input that it expects. And you'll notice that at the beginning of the video when we did a demonstration, this is what popped up in Claude Code as the input that it wanted us to approve as it sent the request to this MCP server. And then how to determine the date, we give it all sorts of instructions for how to determine it so that the date is always correct, so that Claude doesn't just randomly pick a date or guess the date incorrectly. We give it all the criteria for making sure that the date is in the format and is accurate to the functionality that we want it to have. Then we give it examples of what a user might input and what this tool call would look like, and then an array of meal objects from the specified date so that it knows what's going to come, so that Claude knows what's going to come back from this tool. And then we give it a bunch of instructions on what to do with the output. Filter results only to include entries with valid dates matching the requested date. So we're going to leave out all of the other dates that may be in this tracker. So we have 12/12 and then we have 12/19. We're only interested in the day that we are actually requesting about. So we tell it that. Ignore rows with empty dates. And so basically, we just get very, very detailed about what the tool should do, when it should be used, what it expects from Claude, and what Claude should expect back from it after the tool has run. And once you get these descriptions running well, the amazing thing about these MCP servers and connecting them to Claude is that they are what's called non-deterministic, which means that there's a lot of flexibility and covering of edge cases. Basically, Claude is very robust and will figure out when something isn't quite right, how to make it right. Whereas before, you would have to literally code in every single scenario to make sure that you covered every single case that may be used. But that's not the way that these work. These are far more robust, especially when you get the tool descriptions correct, and you can build tools that are incredible. Now, again, I don't want you to get hung up on this example in this exact use case. It is estimated that there are hundreds of millions of APIs that exist globally. So this is not even scratching the surface of what is possible with MCP servers, because there are hundreds of millions of APIs that you can go and access and that you can connect to Claude, basically give Claude legs that it's no longer confined to just the knowledge that it has. It can actually go out and do things. It can connect to any of these hundreds of millions of APIs and do unbelievable things for you. This is why I stress how valuable these MCP servers is because they are so capable. There is an infinite number of combinations that you can put together, an infinite number of tools that you can put together. It can do just about anything that you can imagine. So we're literally gone from where the technical expertise was the limiting factor. Now it's just your imagination. Pretty much, if you can think about it and it exists digitally, you can accomplish it with MCP servers, and you can offload a bunch of the work that you have to do in your life to Claude and to these MCP servers that will save you an enormous amount of time. Now, you can download this exact workflow so you can look at the tool descriptions, you can look at how they're set up so that you can use them as kind of a benchmark or a reference when you're building your own MCP servers. If you go to the link that's in the description, you just create your free zero obligation account at automationhackers.net, and then you go to the NAN workflows, and this will be available for you to download, and you'll be able to put this in your own NAN instance and look at it yourself to help act as a guide or a reference when you're building your own MCP server. So I'd encourage you to do that. You'll also be able to get access to all of the other workflows that are included with all the other videos on the channel, and they're all free, and you can just upload them into your own N8N instance, and you can use them as a reference, or you can just, if you're really interested in just tracking your nutrition, then you can just change out your API token and your Google credentials and hook it up to your own Google Sheet, and you'll be able to just use this as a nutrition tracker. So I would encourage you to download the workflow, and it will help you to have a vision of what's possible for you as you let your imagination run wild and start automating some of the tasks that you have, and outsourcing them to Claude Desktop.